In this video, I want to introduce you to the idea of plotting kinematics on a graph and interpreting them. So remember from last week, kinematics, what I mean by that is I mean joint angles primarily and their orientation in space. So this is going to get us into the context of defining our joint angle convention and talking about flexion and extension or abduction, adduction. So a really common technique to be able to think in a clear way about what's happening at the joints of the body is to plot the joint angle or multiple joint angles over time. So I have a figure of that here, which we'll look at in detail. But the idea is, suppose we are interested in hip flexion during running. So here is the hip joint. And we're interested in what is the angle of the hip, meaning how flexed or extended is it during running. What we can do is we can, first of all, define our joint conventions. So let's say 0 degrees equals thigh in line with torso. So 0 degrees, maybe I'll just draw it. 0 degrees equals torso like this, hip like this. So define that equals 0 degrees. And number 2, let's define positive as being hip flexion. So that means rotating this way is going to be positive. So what we can do once we've done that is we can take some data that we have and we can make a plot over time of hip angle. And that's what we're looking at right here. So first off, let me pull up OpenSim here, and I'm just going to run this animation for a little while, and we'll look at what's happening. So notice this is one full gait cycle of running, and we're looking at the right hip, which is the one closest to the camera, and we're looking at the amount of flexion. This is following the same joint conventions that we just talked about. So I'm going to pause this right when hip flexion gets to about 0. And it's a little bit of a pain because the plotter doesn't quite stay up at the same time as the simulation. But notice this, by the way, hopefully you can see this blue dashed line shows us what current time frame we're at. And notice right now we're at close to just a little bit more than 0 degrees. We're at about 4 degrees of hip flexion, which means that the angle of the hip joint, the angle between this segment and the pelvis, is just ever so slightly more flexed than our neutral position. If I start that animation up again, and let's pause this at a point where the hip is highly flexed. So notice the right hip is moving into flexion. I'm going to pause it right now. Notice now we're at about 50 degrees of hip flexion, which means that the angle between the thigh and the pelvis is about 50 degrees, positive 50. I'm going to do the same thing, and this time I'm going to pause when the hip is in extension. So we'll wait for the gait cycle to finish again. We're in flexion right now, and moving back into extension. So right now, notice the hip is in a highly extended state. We're at about negative 10 degrees, which means hip extension. So angle between this segment and the pelvis is a negative number. So you can see that when you plot it, and we can start to build a vocabulary of the important points on this plot. So the first one that I want to point out, let's maybe make a little list over here. Important points. First off, neutral. What is a neutral joint angle? That means When are we at 0 degrees? So an easy way to see that is just draw a dashed line along 0. And you'll notice that in this running gait cycle, there are 2 points. Oops, you can't really see that very well. Right there and right there, where we're at a neutral joint position. Sometimes you won't get to a neutral joint position. In running, for example, your knee will quite often never get fully extended. So the knee flexion plot might be up here. It might never actually touch 0. But a common term you will hear is neutral joint position, which means 0 degrees. Let's also think about being in flexion. And I'm going to write also being an extension, because obviously that's just the opposite. So what does it mean to be in hip flexion? That means our hip is in a position that is in the direction of extension, meaning positive, right? Because that's how we defined our joint convention. So what that means is anytime this curve is above 0, meaning anytime it's in this area of the plot, then our hip position is in flexion. So this whole time we are in hip flexion, and this whole time we're in hip flexion. Now, you can see where this is going. So let me give you a color key there. When we're in hip extension, it's just the opposite, right? When we're below 0, that doesn't show up very well. That's better. When we're down here, that's being, our hip position is in extension, meaning our hip is beyond the neutral point, like it is right here. And we already mentioned those are the neutral points. Now, that's pretty straightforward, but let's talk about something a tiny bit more complicated, which is moving in the direction of flexion or extension. Let's say we talked about this last week, and I put this in the notes to try and clarify it, because it's a little bit tricky. So equivalently, I'm using this kind of convoluted big phrase to really specify what I mean, but colloquially you will hear me and other people just say flexing, like verb, the verb. And what that means is that our change, our delta of angle is towards flexion. So when on this graph are we flexing the hip? So that would mean that wherever we are, we're at some point. Let's just pick a point. Let's say like right here. Are we flexing the hip? Well, I'm going to say no, because we just said back up here, hip flexion is when you're up in this part, and hip extension is when you're down in this part. So if this is flex, extend, to be flexing the hip, we need to be moving towards flexion. We're actually moving towards extension here. So even though our position, say like right here, the hip is in a position of flexion, it is extending. What you can think about, maybe the easiest way to think about it is, what direction is it moving? So let's say we're right here. You can see that as time goes along, we're going up this way. We're going towards flexion. So at this point, I would say we are moving in the direction of flexion, or we're flexing the hip. I know some of you are experienced in calculus, and so if you are, one way to think about that is it's the slope of the curve here. So when the slope is negative, that means we're moving in the direction of negative. We defined negative meaning extension. And if the slope of this curve is positive, that means we're moving in the direction of flexion, because we defined positive as flexion. If that didn't make any sense to you, if you haven't done calculus, don't worry about it, but it might be a useful way of thinking about this if you have been exposed to that idea before. Okay, so this is a little bit of a technical thing. Let me show you the animation again, and let's just look at what's happening, say, when the hip is going to be moving in the direction of flexion. So let me pause right here and notice at this point we're going to be going up. So we're going to be going positive, and positive is flexion. So we're going to be moving in the direction of flexion, even though at this current point, well, I guess, okay, we are flexed because we're at about, what, 4 degrees of hip flexion. So let me I'll slow this down even more, and we'll just notice how, and I'll back it up a little bit, and notice how this hip angle is increasing. And by increasing, I mean getting more positive. So when we transition to moving in the direction of flexion, that's going to happen right now. And notice how the thigh is swinging forward and increasing the hip angle. And then right here, we switch back to extending the hip. So right now, the hip is extending. Hopefully that gives you a little bit of vocabulary to think about flexion and extension versus moving in flexion and extension. There are 3 more things I want to point out. Those 3 things are a little bit more straightforward. They are, I'll write it up here on in the white space, maximum flexion. So the position of maximum flexion, the position of maximum extension. You'll be happy to hear that these are relatively straightforward. So maximum flexion just means the point on the graph where we are the most flexed. So that would be wherever this line is at its greatest value, because we defined flexion as positive in this case, right? So that'd be like right there. So the most flexed our hip ever gets is, what, maybe 55 degrees, reading off the coordinates here. Maximum extension is the opposite. How negative does it get? Well, down here, the minimum value, so maybe negative 10. So let me just write that out. Maximum flexion was positive, let's say it was positive 55. Maximum extension was negative 10. Notice, by the way, how I'm using the same like number scale here. So I'm not saying 10. I'm saying negative 10. A negative 10 degree angle at the hip. And the reason I'm saying that is to bring us to our third thing that I want to close with, which is range of motion also known as excursion. You could probably guess what this is going to be. It's just the absolute difference between these two. So it's how much of a total range of motion do we need to complete this motion. It's like, what is that height? The max, the max minus the min. So to go from negative 10 to positive 55, we have a total range of motion of what, 65 degrees? Now, range of motion is a little bit of a tricky term because sometimes people use it to mean how far away from neutral can you get. In clinical settings, quite often you'll see people talking about range of motion in each direction. So maybe somebody is not very flexible and they only have, say, 40 degrees of flexion range of motion and maybe 10 degrees of extension range of motion. I will, because of this confusion, this is kind of becoming a theme in this class, I will use the term excursion, and I'll try and be really clear that I mean max minus min, or the total like range of angles that you sweep through in this. So hopefully you found this graphical interpretation of kinematics a relatively straightforward idea. It is super useful because we can not only look at one joint, but eventually later in this class what we'll be doing is we'll maybe plot hip angle and knee angle and ankle angle as a function of time. So maybe the hip angle is doing something like this, the knee angle is doing something like this, the ankle angle is doing something like this, and we'll be able to, at any particular point in time, compare what's happening at the hip, what's happening at the knee, what's happening at the ankle. And in weeks in the future, we will also discover that we could do the same thing with, say, torque or with forces or pretty much any other biomechanical quantity that we might be interested in.